Okay, moving on to question 4, the elevator question, and I apologize that the drawing is on the next page. We're asked to determine the tension in the elevator cable. So for the elevator cable, and I'm scrolling to the next page to do my free body diagram, I'm going to choose the system of the elevator. Bless you. Elevator plus the man, because I want to know the tension in the cable. So here is the tension on the elevator by the cable. This is the weight force on the elevator by the earth. And that's it. That's all I've got. Okay, so going back to answer the question, determine the tension in the elevator cable. So net force in the Y equals MAY. So tension is positive, so I'm going to say tension on the elevator by the cable minus the weight force is going to be equal to MAY. Now acceleration was given, it's going 3 meters per second upwards. Okay, so tension is equal to weight force plus MAY, but the weight force is equal to mg, or tension in the elevator cable is equal to mass times gravity plus acceleration. Now here's where it gets interesting, because we need to consider the mass of the elevator plus the man. Okay, that's our system, elevator plus the man. So 250 kilograms plus 80 kilograms. Gravity is 10 meters per second squared. Acceleration is 3. So first we get 330 kilograms squared. Kilograms times 13 meters per second squared. So that's going to give us 4,290 newtons. Apologize for the noise in the background. I'm in a bit of a noisy area, so I apologize for that. Okay, I'm asked to determine the normal force of the elevator floor against the passenger. So against the passenger is the key here that gives you a hint. So we are talking about the free body diagram of the passenger. So scrolling down here, system is the man. Okay, so I want to draw all the forces acting on the man. So the man has a weight force on the man by the earth, and then he's also got the normal force on the man by the elevator. Okay, so determine the normal force of the elevator floor against the passenger. So net force in the Y equals MAY. So the normal force on the man by the elevator minus the weight force on the man by the earth is going to be equal to the mass times the acceleration, or the normal force is equal to the mass times acceleration plus the weight force, which for him is going to be mg. So his mass times the acceleration in the Y plus gravity. And I know this seems tedious, but learning how to practice these steps of writing the information is really useful. So the man had a mass of 80 kilograms. Acceleration 10 meters per second squared plus 3 meters per second squared. And that is going to equal, let's see, 80 times 13. 1,040 newtons.